Welcome viewers, I am Tutor Cletus Okoli. In today's mathematics class, our topic is symmetric functions of roots. We have about 3 questions that we want to solve under the topic. And the question says, if the roots of the quadratic equation 2x to the power 2 plus 5x plus 3 equal to 0 are alpha and beta, what are the values of question A, B, and C? I want you to watch this video to the end. But before we start with the solution, I want you to know it is very important that we know what the sum and product of roots are. And when we know that, it will help us to solve this question very easily. We dive in. Remember to stick to the end. From question A, first and foremost, alpha plus beta is equal to the sum of roots, and we are going to take it from the question that we are given, which is 2x to the power 2 plus 5x plus 3 equal to 0. From this question that we are given, I want you to see this quadratic format: ax squared plus bx plus c equal to 0. What will we do? We are going to compare the values of a, b, and c so that we can be able to know the sum of roots. And the sum of roots is given by minus b all over a. And our b, as you can see here, if you compare it with the equation that we are given, our b is 5. So minus b will now give us minus 5 all over a, and our a, when compared with the equation that we are given, you see that our a is 2. So we can simply say that the sum of roots is equal to minus 5 all over 2. Next, we need to get the product of the roots, and that is going to be equal to c all over a. So this implies that for the product of the roots, our c, if you compare with the format of quadratic equation, you see that our c here is 3, whereas our a is still 2. Now that we have gotten the sum of roots and the product of roots, we can now go ahead to solving the question that we are given in question A, B, and C. Thank you. Then in question A, I am given that I should find alpha squared plus beta squared. That is what question A says that I should do. But then I need to know what to do, because my interest area is to manipulate this question in such a way that I can get my values in terms of sum of the roots and the product of the roots. So that way I can now be able to solve the problem. Alright, let's see how we can manipulate this alpha squared plus beta squared to be in either sum of the roots or product of roots, or even both. Therefore, from this, let me have alpha plus beta squared, and from here I will be able to get alpha squared plus beta squared, what it should be. Now, if I open this bracket, this is alpha plus beta squared. What I shall have is alpha squared, then plus beta squared, then plus 2 alpha beta. Alright, the result of this bracket is equal to this. And from here you can see with me that I have here alpha plus beta, which is exactly what I am given to find. So I can make subject to the formula, and that implies that I shall take 2 alpha beta from the right hand side to the left hand side to now get alpha plus beta, then to the power 2, then bringing 2 alpha beta to the left hand side, I shall have alpha beta equal to alpha squared plus beta squared. We can now say from what we are asked to solve that alpha squared plus beta squared is the same thing as alpha plus beta all to the power 2, then minus 2, then alpha beta. With this now, I can get the value of alpha squared plus beta squared, because I have seen what it is when I simplify it to be in terms of the sum of the roots and the product of the roots. Therefore, from here we have gotten the sum of the roots to be negative 5 all over 2. So I will now write negative 5 all over 2 to the power 2 minus 2 multiplied by the product of the roots, which we got here to be 3 over 2. So 3 all over 2. You can see that 2 can cancel 2 here, and the square of negative 5 all over 2 is going to give me 25 all over 4. Then, if I cancel 2 and 2, what I have left is minus 3. Permit me to write it this way, that 25 over 4 is the same thing as 6 whole number, 1 all over 4, then minus 3, which is now going to give me 6 minus 3 will give me 3, 1 over 4, or 4 times 3 plus 1, 13 all over 4. Answer. So we have gotten the first answer in question A. We are asked to find alpha squared plus beta squared, and after solving it, our final answer is 13 all over 4, or as a mixed fraction, 3 whole number 1 all over 4. Okay? So, that is that. Then we go to the question B. In question B, we are given to find beta over alpha, then plus alpha over beta. We are given to find beta all over alpha plus alpha all over beta. Like I said, we have to manipulate this to make sure that it comes in terms of product of the roots and the sum of the roots. So to do that, first and foremost, I want to find the LCM of the two expressions, and that is going to give me alpha beta, meaning that alpha divided alpha beta is going to give me beta, and beta times beta will give me beta squared. Also, if I use beta to divide alpha beta, I will get alpha, and alpha times alpha will give me alpha beta. If you look at this now, you see that what we have here, because you know that x plus y is the same thing as y plus x. So what we are saying in essence is that this is a symmetric function. Therefore, beta squared plus alpha squared is the same thing as alpha squared plus beta squared, because addition is commutative. Alright? Meaning that 2 plus 3 is equal to 5, and also 3 plus 2 is also equal to 5. So that is the commutativity of addition, implying that I can now write this as alpha squared plus beta squared all over alpha beta. Now, but we have already simplified something like this, and the result we got for alpha squared plus beta squared is what we have here written. So I can now write it as alpha plus beta squared, then minus 2 alpha beta. Everything now is all over alpha beta. Also, we may not bother ourselves trying to simplify the numerator again, since that is exactly what we did in question A, and our answer came out as 13 over 4. So what we need to do now is to simply move the result of the question A, which is exactly what we have here at the numerator, and then write it as 13 all over 4, then divided by alpha beta. And our alpha beta is going to be, from what we have here, the product of the roots, which is 3 over 2. So we are going to divide the numerator, which is 13 all over 4, by 3 all over 2. And when this happens, we shall have 13 all over 4 multiplied by 2 all over 3. 2 here is 1, and 2 here is 2. This means that what I shall have now is 13, okay, all over 2 times 3, which is equal to 6. And this can be written as a mixed fraction as 2 whole number 1 all over 6. So this is the result of question B that said that we should evaluate beta all over alpha plus alpha all over beta. And having done that, our answer is 2 whole number 1 over 6. Beautiful. Then let's go to the question number C. In number C, we are given to simplify 1 all over alpha squared, then plus 1 all over beta squared. Like I said, we have to also work on it and then see how we can put it as sum of roots and product of roots. That implies my LCM is going to be alpha beta, that is alpha squared beta squared. Then, when I now use alpha squared to divide alpha squared beta squared, what I shall have is beta squared. And beta squared times 1 is going to give me beta squared. Then, plus, if I also use beta squared to divide alpha squared beta squared, I shall have beta squared cancelled out and then left with the alpha squared. And when I use alpha squared to multiply 1, I shall have alpha squared. So, from what I did in question number B, I told you that alpha squared plus beta squared plus alpha squared is the same thing as alpha squared plus beta squared. So I can rearrange this now to have alpha squared plus beta squared all over. Of course, alpha squared beta squared is the same thing as alpha beta squared. So this is very nice. Also, if I wish to expand this alpha squared plus beta squared to be exactly like I did in number A, at the end of the day, my result shall be alpha plus beta all squared minus 2 alpha beta. But then, the result I will get is exactly what I got here, which is 13 all over 4. So, it is very important if I just move straight, substituting the value of alpha squared plus beta squared, since that is exactly what I am asked in question A, and my answer came out as, 13 all over 4. So let's substitute it because we have already expanded it in A and in B. And this time around, since it's coming up again, we just put the value of the answer. So that answer is simply 13 all over 4. So divided by alpha beta squared. And my alpha beta from the product of the root is 3 all over 2. So I will now write divided by 3 over 2 squared, because you can see that my alpha beta is squared at the denominator. So this implies that I shall have 13 all over 4 divided by 9 all over 4, because the square of 3 is 2, the square of 3 is 9, and the square of 2 is 4. So this implies that I shall have 13 all over 4 multiplied by 4 all over 9. And when 4 cancels 4, what I shall now have left is 13 all over 9, which can be written as one whole number, then 4 all over 9. Final answer. So in conclusion to this class today, our 3 questions are already solved. In question A, our answer is 3 whole number 1 over 4 or 13 all over 4, and that is the solution to alpha squared plus beta squared. And in question B, where we are given beta all over alpha plus alpha all over beta, the final result that we got there is simply 13 all over 6, or as a mixed fraction, 2 whole number 1 over 6. And in question number 3, where we are asked 1 all over alpha squared plus 1 all over beta squared, after simplifying it, the final answer is 13 all over 9, or as a mixed fraction, 1 whole number 4 all over 9. Thank you for watching this video to the end. Please give me a thumbs up and share my videos. God bless you.
Na mbụ agwara m mmadụ sị